Mystery, mystery, mystery. And here we are with the third postulate of Bohr of hydrogen atom. Quite a simple and quite a complex theory it is. The postulate 3 suggested us that despite of the fact that electron remains in an orbit with constant acceleration, an electron moving is allowed in permissible orbit, it does not radiate any energy. So the energy remains constant. And we know these orbits are called as stationary orbits, don't we? Somewhat like this. So what happens if you tease the electron? What happens to it? Electron gets excited. It stays there for some time. That means it goes to foreign country for some time. It comes back. It goes there, it comes back. It goes there, it comes back. That means electromagnetic radiation is emitted if an electron initially moving in an orbit of total energy EP discontinuously changes its motion so that it moves in an orbit of energy EM. Oh, what does this mean? Let me show you the diagram. The diagram is, first, it says that a photon, bright light is coming. So bright light comes. The electron gets excited. And after staying there for some time, it comes back, photon gets disappear. So once again, photon comes, electron comes back and photon disappears. Once again, photon comes, electron comes back, disappear. That's what the entire postulate is. So to summarize the third postulate, the difference of energy between two orbits, that is EP and EN, is equal to h nu. What is nu? Frequency, of course. So that's what the entire diagram is. Your electron goes from down to up or up to down. That difference of energy is your photon's energy. Happy birthday. Postulate 3 was born. So to demonstrate it one last time, we have two orbits, EN and EP. Now, there is an electron in EP. It goes to EN and it emits a photon. Oh, fine. If it emits a photon of h nu, then EP minus EN is equal to h nu, that is equal to hc by lambda. Third postulate is born. So now let us have a look at the idea of stationary orbits. Bohr postulates. The stationary orbit, first it said that these are orbits in which electron does not radiate any energy, in which the angular momentum is quantized. That is, L is equal to mvr, that is equal to nh upon 2 pi. But then we have the emission of photons. When electron goes from higher orbit to its lower orbit, it removes the photons, and when it absorbs the photon, it goes up. Dear students, take a pen, take a notebook and draw this table. This is called tree diagram, in which I will show you the three postulates. Postulate number 1, CPF is equal to electrostatic force, in which mv square by r is equal to 1 upon 4 pi epsilon 0 e square by r square. Simple. Then we have postulate number 2, in which the angular momentum of the orbits are quantized and L is equal to nh khali 2 pi. nh khali 2 pi, 2 pi. L has three formula. I omega, I is equal to mr square, so mr square omega, and r omega is equal to v, so mvr. And third, our darling postulate, whenever electron is teased, when it is done this way, it excites, we get de-excited. So En minus Ep is equal to h, that is equal to hc by lambda. So a physicist is just an atoms away at looking at himself. Buddy, you are genius, you are a true businessman, a great philosopher. I will get back to you with awesome modules and awesome numericals. Stay tuned.